Good afternoon, my student. Welcome to a chemistry lesson. And today's lesson, we are going to discuss about energy changes in physical and chemical processes. Energy changes in physical and chemical processes. Then when we talk of energy changes, we are talking about what we call changes in heat, and this one is measured using the temperatures, and in this case we are going to look at two types of reaction. We have what we call endothermic reaction and exothermic reaction. So at the end of this lesson, my student, you must be able to distinguish between endothermic reactions and exothermic reaction. So my student, without wasting time, I have apparatus here and some chemical reagents we are going to use in this lesson. Let me take you through very fast. So first of all, I have two plastic beakers which are 250 ml. Is it okay? Then I have 100 measuring cylinder. Then I have a thermometer. Then I also have metallic spatulas. Then I have distilled water in a plastic beaker. Then I have rubber bands. Then also I have pieces of tissue papers. Then I have the salts. I have two reagents. The salts. One of the salt is sodium hydroxide salt. Is it okay? Then another one is ammonium nitrate salt. So my student, I want now to take you through the procedure. It's a simple exercise that takes only about 15 minutes. Is it okay? So I'm going first of all, the first procedure, to secure these two plastic beakers with a piece of tissue paper supported by a rubber band. Is it okay? So there we go. So this is what I'm going to do. I'm going to take the plastic beaker, then I secure it with a piece of tissue paper like this, like that. Then I have to support it with a rubber band like this. At least two rubber bands like that. Then I also do the same with this one, Also do the same to this one, like that. Hope you are following the procedure, my students, like that. And I also secure it with a rubber band. At least two rubber bands are enough. Is it okay? So I have secured them with that piece of tissue paper. Is it okay? Then I have now to measure, using a measuring cylinder, 100 ml of distilled water like this into each beaker. This is 100 ml of water. I transfer into each beaker like this. Then I also measure 100 ml again. I transfer into the other beaker also, like this. So that's the second procedure. I've transferred 100 ml of distilled water in each beaker. Is it okay? So my student, the next procedure, I'm going to take the steady temperature of this distilled water using a thermometer like this. Then we have to read the temperature of this water. Is it okay? Then I'm going to use ammonium nitrate first, dissolve it in this distilled water, then take the temperature, the final temperature. I take the final temperature after adding the salt. Is it okay? So before I add the salt, let me first of all read the steady temperature of this water. It is 24. It is 24. Is it okay? You're saying it is 24? And sure it is 24. Is it okay? 24 degrees Celsius. And we normally say 0.0 degrees Celsius in this case. Is it okay? Then I'm going to add now the 2 spatula. I'm going to add 2 full spatula into this distilled water. Then I'm going to start using the thermometer, and then we read the final temperature. Is it okay? Good. Let us go. So I'm going to take 2 full spatula. That is 1. That is 2. And my student, please concentrate. I'm seeing you concentrating outside. That is wrong. Concentrate to this one. Very important. So I'm going now to start using the thermometer like this until all the ammonium nitrate salt dissolves. Then we read the final temperature. Is it okay? It is a simple exercise, my student. At the end, we'll understand what happens when ammonium nitrate dissolves in water. Is it okay? The solid has dissolved. Then let us read the temperature. The temperature is 19. The final temperature is 19. Are you able to see? Are you able to see, my student? It is 19. 19.0 degrees Celsius. Thank you. So what has happened, my student? When ammonium nitrate salt dissolves in water, the temperature drops. Initially, water had 24 degrees Celsius. Then it has dropped to 19 degrees Celsius. It means when ammonium nitrate salt, when it dissolves in water, the heat is absorbed into the reaction. Is it okay? What we call endothermic reaction. Endothermic reaction. Thank you. Before I explain further, let us also repeat the same procedure now using sodium hydroxide. We dissolve now sodium hydroxide. And you have to wipe the thermometer. You have to wipe the thermometer because I'm using the same thermometer. Is it okay? Then I also take the state temperature of this distilled water. Let me again take the state temperature of this distilled water before adding sodium hydroxide. Is it okay, my student? And hope you are concentrating. This one requires your total concentration. Total concentration. It is also 24. This water have the same steady temperature. It is also 24.0. Is it okay? Yeah, 24.0 degrees Celsius. So I'm also, and please ensure you don't contaminate the solids. So I use different spatulas. So this one are pellets of sodium hydroxide pellets. I'm also going to measure 2 spatula. Is it okay? Let us go. Let us go. Let us go. 1 spatula. 2. Is it okay? Then my student, I now start stirring using the thermometer and now read the final temperature when sodium hydroxide has dissolved. Let us go. And please don't remove the thermometer. Don't make a mistake of removing the thermometer until all the solid has dissolved. Is it okay? And then read the final temperature. And this one require your patience, my student. I have been always saying that. Require your patience. And you have to be very keen. You have to be very keen. So the solid has dissolved and the temperature is about 40. You can see 40 degrees Celsius. Are you seeing? Are you seeing, my student? It is 40. Confirm and see. Good. So when sodium hydroxide dissolves in water, the temperature rises. The temperature rises from 24.0 to 40.0 degrees Celsius. Meaning that when sodium hydroxide dissolves in water, temperature rises. What we call exothermic reaction. Exothermic reaction. Meaning this reaction is giving out heat. It is releasing heat to the surrounding. Is it okay, my student? So in 1 minute, let me now explain further on the board before I conclude. So my student, without wasting time, I'm talking about endothermic and exothermic reaction. So let us look at endothermic. Endothermic. Endothermic reaction. When ammonium nitrate solid dissolves in water, it dissolves to form ammonium nitrate solution or aqueous ammonium nitrate. Is it okay? And we are saying that in this case temperature drops because heat is absorbed into this reaction. Is it okay? So it means because when the reactant reacts, heat is absorbed, it means the product formed have more energy. So the products have more energy compared to the reactants. Is it okay? So we can represent this one in what we call energy level diagram like this. This reaction like this, like this. Where we have here energy in kilojoules. Then here we have what we call reaction progress. So when we are representing this, the reactants will be here. Then after the heat change, the products are here. These are the products. Then these are the reactants. These are the reactants. So reactants here is ammonium nitrate solid plus what? Plus water liquid. Is it okay? Then the product is now aqueous ammonia. Now this is not aqueous ammonia but aqueous ammonium nitrate like this. Is it okay? So here we place there the sign for heat change, what we call enthalpy change. And the sign here is positive because this is a endothermic reaction. Why positive? Look, let's say for example, this is the energy. Let's say this is 0 and maybe this is 10, maybe this is 10 kilojoules. So when you extrapolate on the product side like this one will be like what? Let's say 30 kilojoules. So it means reactants have less energy, let's say 10 kilojoules. Then products have 30, it means product have more energy. Why? Because during the reaction, the system absorbs heat energy. Is it okay? And why is it that the heat change is always positive? We normally say that to get heat change is equal to heat of the products minus heat of the reactants. Is it okay? So what is the heat of the product? It is the 30. So if you take 30 minus heat of the reactant, that is energy of the reactants, you get, that is 10, which is equal to 20 kilojoules. For example, this 20 kilojoules for example. And this 20 is what? Positive. So if the enthalpy of the product is more than enthalpy of the reactants, always the heat change will be positive. Endothermic reaction. Then let us look at for the case of sodium hydroxide. Let us now look at exothermic reaction. Exothermic reaction. Sodium hydroxide solid. When you dissolve it in water, you get aqueous sodium hydroxide. Is it okay? So temperature was rising from 24.0 to 40.0. What does that mean? We can also represent this information on what we call an energy level diagram this way. So here the reactants were able to lose some heat to the surrounding. So it means the product formed have less energy. We are in agreement, isn't it? So we can also represent this one on an energy level diagram like this. Where on the y-axis we have energy in kilojoules. Then on the x-axis we have reaction progress. So because the reactants have more energy than the product, because heat was lost, we represent it this way, like this, so that here we have the reactants having more energy, then here we have the products having less energy. Then here is this what? The sign for heat change, which is negative. The sign for heat change for exothermic reaction is negative, and I'm going to explain that. So what are the reactants here? It is sodium hydroxide solid. Sodium hydroxide solid plus what? Plus water, dissolving in water liquid to form a sodium hydroxide solution. Sodium hydroxide solution or aqueous sodium hydroxide. Is it okay? Why is it that the heat change is negative in exothermic reaction? Good. Look. For example, I can extrapolate up to this point and assume, let's say this one is just like the other one. Let's say this is 10 kilojoules. Then for the reactants, the reactants are up here and say it is what? 30. Let's assume it is 30. Is it okay? Because energy as you move upward, it is increasing. So you find that reactants have 30 kilojoules. Then the products have 10 kilojoules. So if you calculate heat change or enthalpy change, it is given by heat of the product minus heat of the reactants, isn't it? Let us look at the heat of the product. It is, the products are down here, 10 kilojoules for example, 10 kilojoules minus heat of the reactants. The reactants are up here, they have 30 kilojoules. So 10 minus 30, my student, 10 minus 30, what do you get? Negative 20, look, negative 20 kilojoules. So that is it now. That's why we say that for exothermic reaction, the enthalpy change is negative. Is it okay, my student? Because the enthalpy of the product is less than enthalpy of the reactants. So my student, up to this point, this is enough for you now to understand enthalpy changes. And whatever we discuss in subsequent lessons will depend on these two. Have you understood endothermic and exothermic reaction? Thank you, my student. I'm Mr. KW, a teacher of chemistry. Until next time, thank you.